Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of derivatives. So as per the problem, find the maximum and minimum values of the function, and the function is y equals 2x times e to the power 2x. So the first step is to find the derivative of this function, because we'll set the derivative equal to 0 to find the x values at which the tangent is horizontal, because the tangent is horizontal at peaks and valleys in the graph of the function. So let's start with the derivative. Now this function is made up of two types of functions. The first function is the polynomial function, which is 2x, and the exponential function e to the power 2x. And these functions are being multiplied, so we have to use product rule to find its derivative. So we'll start with the derivative of the first function, and the first function 2 is the coefficient, so it will stay as it is, and the derivative of x is 1, times the second function, and then plus the first function times the derivative of the second function. The second function is the exponential function with base e, so its derivative is the e term itself, times the derivative of the exponent, and the exponent is 2x. And in this 2x, 2 is the coefficient, so it will stay as it is, and the derivative of x is 1. Now we can simplify this expression. So 2 times 1 is 2, so we multiply 2 by the e term, plus, now 2 times 1 is 2, so we can multiply the two 2's, so we get, now we can factor this expression, so we can do common factoring. We can factor out 2 and e to the power 2x. So we are left with, now we can set the derivative equal to 0 and then solve for x. So now we have to analyze the cases. So the coefficient 2 is just a constant, so it won't give us any solution for this equation. So the first case is, now there is no x value that will make this exponential term equal to 0, so we get no solution from this case. Now we can analyze the second case. So we have to solve for x. So first we have to subtract 1 from both sides. The ones on the left side get cancelled out. And now we can divide both sides by 2. So 2's on the left side get cancelled out. So this is a critical number for this given function. Now we can use the first derivative test to analyze this critical number to find whether it represents a local maximum or local minimum. So we have to find the sign of the first derivative on the left side and the right side of this critical number. So we can use the number line method. So we can show this critical number. So this critical number divides the number line into two parts. So we have to use a test value from each part. So from the left part, we can use the test value -1, and from the right side we can use the test value 0. So we have to sub in these test values one by one in the derivative of the function, and if the derivative is greater than 0, that means the function is increasing, and if the derivative is less than 0, that means the function is decreasing. So we can use this equation. So let's start with x equals -1. So we should sub in x as -1 in the derivative. So now we can simplify this expression. So in the exponent, 2 times -1 is -2. In the parentheses, 2 times -1 is -2, and 1 plus -2 is -1. Now we can evaluate this expression. So I got a negative value, -0.27. So I rounded the answer to 4 decimal places. Now this value is less than 0. That means on the left side of the critical number, the function is decreasing. Now we can do the analysis for the right side of the critical number. So we'll sub in x as 0 in the first derivative. So in the exponent, 2 times 0 is 0. And in the parentheses, 2 times 0 is 0. So 1 plus 0 is just 1. So now 2 times, so e to the power 0 is 1. So the result will be 2, which is greater than 0. That means the function is increasing on the right side of this critical number. Now since the function is decreasing on the left side and increasing on the right side, that means there is a local minimum at this critical number. So we can find the minimum value of this function by subbing in x as -½ in the given function equation. So I sub in x as -½ in the given function. So 2 times -½ is -1. And then in the exponent, 2 times -½ is -1. Now we can evaluate this expression. So I got negative. So this is the minimum value for this function. Now this function has no critical number at which there is a local maximum. So that means this function has no maximum value. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.